In fourth grade, we do various strategies for multiplication, and it's important that students have an understanding of place value. It plays a very big part in how they can easily get from one strategy to the other, or at least recognize the differences between them. So I want to show you what we are doing with our fourth graders, how we're teaching them to recognize each one of these strategies. So we have 63 times 4. The standard algorithm, which is what I learned in school, what you guys learned in school, is stacking your numbers on top of each other, and it's going to look like this. Now, as far as doing that for the distributive property, we're going to actually take that 63 and we're going to do an expanded form version of that. So instead of 63, we're going to say 60 plus 3. And then, of course, we've got to keep in there that we are multiplying by 4. So as we explain this to the students, it's just like as we hand out papers to everyone, we want to make sure that everybody has a paper. So in this way, we're passing out the 4. We're distributing it to everybody that is within this equation. So we need to make sure that we do 4 times 60, and then we're going to add the 4 times 3. And of course these would be enclosed with parentheses to make sure that that is what we take care of first, which if you follow the order of operations, you don't really have to do that, but it's helpful for students to see them group the groupings of them separately. So we have 4 times 6, which is 24. So they would notice that that 6 is in the tens place. So though 4 times 6 is 24, we also know that 4 times 6 tens is 24 tens, or as we would know it, 240. And then we would add 4 times 3, which is 12. And then we would add those two numbers together. So when we combine them, we get 2 ones. 4 plus 1 is 5, so 5 tens and 2 hundreds. So this is what we would generally look at whenever we are doing specifically the distributive property. So how does that look everywhere else? Well, on partial product, we're still wanting to make sure that we cover our basis everywhere. So if we have 63 times 4, partial product just means we are going to list out all the numbers that we are multiplying. So we've got our 4 ones times our 3 ones. And then we're also going to do our 4 ones times our 6 tens. And that's really important for them to not just see it as 4 times 6, which in standard algorithm, which again is how I was taught early on in school, following these steps. It's always worked, I understand. But this really shows the students that we're not just doing 6 times 4, we're doing 4 times 6 tens specifically. So here we would see that play itself out with that 12, which we did see here. And then here we would see 4 times 60, which is 240. So the only real difference that we see here is you have the distributive property playing itself out here by rearranging our number sum, grouping them together with parentheses, and it goes further down. Where on the partial product, the only thing we're doing differently is we're stacking the numbers and we're listing everything we are multiplying together and adding vertically. So not a huge difference. How that translates to an area model is, the thing is the area model, through the years, it seems like a lot of feedback is that the area model, people just feel like it's a waste of time in some ways. But you've got people who are more of like list makers. This makes a lot more sense to them. You have people that are more visual. You have people that eventually, and in 5th grade, they're going to want them to be back at that standard algorithm. But our 4th grade standards want them to really take apart what's happening within a multiplication equation. So here we've got 63 times 4. And we did talk about the distributive property, which would be 4 times 60 plus 3. So how that's going to look on an area model is our 4 is going to go here times, and then we've got 63. So we would again say 4 times 6 tens is 24 tens, or 4 times 60 is 240. 4 times 3 is 12. Now this is what we do with area, length times width. So this plays into how we have done those formulas when calculating area, and which is very exactly why we call it the area model. But we have then the 240 plus 12, which we've seen that in the distributive property and in the partial product. And then we get 252. So right now we've got the same answers for all of them. That makes sense. And then we move them over to understanding how that plays into the standard algorithm, so they can explain their steps. So 4 times 3 is 12. And instead of writing it all down here, we would say it's 2 ones, and then we would put that 1 10 over in the tens place. And then we would multiply 4 times 6, which is 24, but we've got to add in the extra 10 that we had to carry, so we get 25. So this is the way that we typically would see it done. But if you notice, when you put all of them together, you can see we're doing the same thing over and over again. It just looks a little different. And usually students will attach themselves to one of these. It's not always the standard algorithm initially. Some of them do prefer to do the area model. It makes more sense. Some of them latch on to the partial product. I see less of the distributive property simply because these are both versions of that. And so they like to either just list them real quickly or put them into an area model for visual purposes. Obviously, this is the less writing, and this is where 5th grade wants us to be. We will get there to where that is how they solved it, but they will also notice, like on KSA, once we get to testing, we would see instances like this where it might say the 63 times 4, and then it might give us 4 times 60 plus, and then we would have to pick multiple choice which one is missing. So they would have to maybe pull in different numbers in order to plug them in to make the equation correct. Over here, the same thing. We might see where they want us to list one of the partial products that is missing in a multiplication equation. And then here we will, this for sure you would see, they may not want to draw boxes normally, but they will see area models where it might say, what is the missing number? Or it may do division where it says, what is the missing number here? So they would have to think, okay, what times 4 is 240? Or 240 divided by 4 is what? So this they will see. They have to be able to recognize that for the test. And of course, like I said, this is the eventual goal. This is how we all do it when we are not using a calculator that is now on our phones. But if you have any questions about it, please let me know. I certainly don't want students to get hung up on this, but I do think it's important that they see how similar these strategies are, and they're using the same exact numbers. We don't ever pull out any kind of new number as we're working through them.